This is the A2 question for November 2010, paper 2 standard level. So as we can see, it's a mechanics question, so it's good to have the mechanics data booklet here. Let's just read it through and we can discuss a bit further. It says, in 1997, a high-speed car with a mass of 1.1 times 10 to the 4 kilograms achieved the world land speed record. The car accelerated uniformly, now that's an important word, uniformly in 2 stages as shown in the table. The car started from rest, also important. So we have this data that is given to us here. Use the data to calculate, so forth. Okay, so we've got our data booklet here, and this is for the mechanics section. All these formulas here are for uniform acceleration, the A and the A. So you really need to know what each of these is. U being for initial velocity, final velocity, S is our displacement, A is our acceleration, T is for time. Our average velocity, if we have our average velocity, is equal to our distance over time, or our displacement over time, depending on what we're looking at. Acceleration obviously is equal to the change in velocity over the change in time, and we can write that as equal to u minus v over t, and we can change that formula around and you can get v is equal to u plus at. That's often an important formula, although we probably won't use it in here. Okay, so the average acceleration, so we're looking at acceleration in stage 1. So we're going to be using this over here. If we're going to get our acceleration, it will be our final. This is what is achieved, our final. Probably here we should write our v minus u, our final minus our initial. So that's going to be 44 minus 0, because it says it started from 0. And we're going to divide by 4 seconds here. So we're going to get 11 meters per second to the minus 2. Then it says the net average force required to accelerate the car in stage 2. Now obviously here we're going to be using this formula over here, and that we'll be able to use to find the net force. But firstly we're going to need to find our acceleration. So in this stage we're going to use the same formula, where our v is now 280, so 280 minus our initial. Now we are going stage 2, our initial would actually be the 44, minus the 44 divided by this time here. So it's from 4 to 12, so it's going to be 8 seconds. So we can calculate that. We're going to get 280 minus 44 equals divided by 8, and you get 29.5 meters per second to the minus 2, and your force is equal to mass, so it's 1.1 times 10 to the 4 times the 29.5. So I multiply that by 1.1 to the power of 4, 10 to the power of 4, and I get this value over here, 324,500 newtons. Now, because all of these are given in 2 significant figures, you see here, 2 significant figures, I must put this to 2 significant figures, so it will be 32,000, or no, it will be more than that. It will be 320,000 newtons, or 3.2 times 10 to the 5. Then it says the total distance traveled in 12 seconds. Now obviously we've got, in this 12 seconds, we've got 2 stages, and each one will have a different, we would have to work with each one separately, because each one has got a different acceleration in each one. So looking at stage 1, Which one of these formulas are we going to use? Probably this one would be the easiest to use, although you can use this one. Yeah, those two would work fine. You could even use this one. You could use all of them. But let's use this one over here. So we're going to get our displacement is equal to u. In the first place, it was 0. It's going to be 4 divided by 2. Sorry, 44 divided by 2 times 4 seconds. It's going to give me 88 meters. And for my 2, I'm going to get S is going to equal 4,280 plus 44 to get that average value there, times by 8. So I'm going to multiply that all by 8. Just do that on the calculator quick. So we're going to get brackets 280 plus 44 close brackets divided by 2 equals times by 8, and I get 1296, and then obviously I have to add the two together, plus 88, and I get 1 equal to 1384 meters. And obviously I have to put this into two significant figures. That's going to be your final answer will be 1,400 meters. Okay, so that's that question.